Welcome back to Workshop Friend as the cold weather continues here in the UK. Today I'm going to do a little exercise on my Colchester student lathe. I need to make a taper shank number 3 morse taper for this chuck. This is my tailstock chuck, which came from overseas, and it's a little bit rough and ready, but it's what I have. It actually has a number 2 morse taper shank with a 3:2 sleeve to fit my lathe. Now the problem is that it's just excessively long. I'm not sure what's out. It's probably this number 2 non-standard taper shank. So of course I could buy a number 3 taper shank and refit that to the chuck, but I thought it'd be more fun to make one, and it would be good exercise in using the taper turning attachment. I'm going to start with mild steel because that's what I've got available, and if it's successful I might buy some better quality steel and make another. Or I might buy one. Anyway, we'll see. So I've cut off 8 inches of mild steel, and it's in the lathe ready to start work. So over to the mill with a horizontal setup for milling the tang. Despite appearances, the setup is actually level. It's just the way my camera is orientated. After deburring, we have the beginnings of the tang on the end there. What I'm going to do now is to face and center the other end so that we can do the rest of the operations between centers. So here I'm skimming the 60-degree point on my soft center prior to turning between centers. So the bracket, which is part of the taper turning attachment, I keep off the machine and only install it when I need it. Incidentally, this is an item which often goes missing, and several of you had written in before expressing interest in the drawings. They're available for anyone else who needs them. On my machine this was missing, so I had to make it from existing dimensions, dimensions that I had from the rest of the machine. Now, one of the features it has in here is this eccentric wheel here. Yeah, so lock this item to the bed. There's still a degree of movement there. So what this does, this eccentric, is it offsets the center line of this clamp with the body. That's because there's going to be a small degree of malalignment. So I lock these up, and then the last thing I do is nip this up here, and that just removes all backlash from the system. Well, this part of the system. There's other backlash which we can talk about later. So now you should see that the taper turning attachment is now connected to the bed, and if we set this at an angle, it traverses the cross slide. Well, that's not far off. This setup, which I'm so carefully executing, was actually wrong. You will find out in a short while what the consequences of that were. So because I set this up closer to the headstock end, I need to move the whole assembly rearwards like that, and then we can begin our cut from the same position on the taper turning attachment. And the mistake is about to manifest itself. In case you haven't already realized, the taper was going in the wrong direction. So fortunately I was able to disconnect the feed quickly enough, and I've measured that diameter there, and it's well above the diameter that the taper should be at that point. That's good news. Taking a bit more care, I'm going to set up and this time clock up on this side, and I'm going to also make sure that the stylus is bang on center height. That's important too. This is my height gauge that I use for setting my tools up, and I've made a very slight adjustment to the height of the stylus there, and the center of it is bang on center height. So we can see here that we need to move the slide on the taper turning attachment this way to increase the angle slightly. Gone too far now. So after fiddling around, I've arrived at this. We start at 0, dips down to -2, comes back up to 0. And that's curious, isn't it? Is that because this is slightly hollow, or is it inaccuracies in my machine? Don't know. Let's just see, let's just ensure that this is concentric. Doesn't look like it is, does it? Oh, the sleeve is a mile out. Okay, so we're going to have to compensate for the sleeve. Now this is interesting. I put one of my older 2 to 3 Morse taper sleeves in there, which is a bit damaged, as you can probably see, but this is definitely more concentric. So I'm going to try with this one, see if we can set up more successfully with this sleeve. Well, after a little bit of fiddling around with this older, probably better quality sleeve, even though it's slightly damaged, I'm getting this result. So that's straight and it's 0 at each end. So if I compare this old, probably better quality sleeve with this new one, which looks nice and tidy, bought fairly recently, the first thing I notice is that apparently that is not straight. Possibly also it's not concentric. So there we are. Some of these cheaper items just don't compare with the old ones. So now I've got everything set up. I've got to slide the whole assembly rearwards for the new position on the work. So my little mistake there is cleaning out. That's not going to be a problem. I'm going to check the minor diameter here. It's very easy to go past size on tapers, so we're going to go cautiously, otherwise this will be undersized and it won't fit properly. Making sure that the tangs line up on the end here, the end of the tangs, so it means that we can compare this diameter here with this diameter. And on the good quality one, we're looking at point. So we've got 49 thou to come off the diameter. So on my metric lathe, I set my dial to 0. That will be 1¼ millimeters off the diameter. Let's just check progress. As I approached final size, I thought I would take the work out and just do a trial fit, and to my disappointment, something's not right. So since it's so cold out here, I thought I'd go inside, have a cup of coffee, take my measuring equipment inside and have a closer look. And what I discovered is this. If I put a straight edge against the taper, you can see, I'll line this up correctly, you can see it's high on the left hand side. I measured this. The taper, the rate of taper between here and here is correct, but that part is parallel. And what's happened is I forgot on that last cut to take out the backlash in the system. If you're interested, there's a video link up here to a previous video I did on using this taper turning attachment, and that explains why there is hysteresis and what you need to do about it. So I need to relearn my own lessons from the past and reverse the direction of cut, moving from the headstock to the tailstock, and that will hopefully remove that problem. Now, all is not lost. I will put this back in the machine, do a finishing cut in this direction. That will mean that this is undersized, but what I'll have to do is just machine this back and cut the end off, and hopefully I'll still have a usable part. Okay, all the settings are the same. All I'm going to do now is traverse in this direction, and I've also put a tool in there with a generous radius, hopefully to slightly improve this surface finish. So I'm going to engage the feed so that backlash is taken out, and then touch off this diameter and take a very small cut. So I've just put a little more feed on there. As you can see, it's just touching, and we're going to come down here and then clean up this end which was missed. So to replicate the proportions on this better quality taper shank, I'm going to relieve this back to this diameter here. So we'll cut this back to this position, and then later on we'll have to relieve this as well. To cut the parallel diameter again, I just need to release the clamp. So now that slides. Okay, there's a bit of drag on there, so what we'll do is we'll disconnect it all together so that we don't run the risk of it cutting a taper. So we'll take that right off. Okay, well there's the surface finish. That's come out very nicely. But surface finish is not everything. Dimensions are what really matter often, so we'll give this a try. That seems to be a good fit. So we can also look at the length of the tang. So that's ejecting at that point just before the 0 line. So we need to take about a quarter of an inch, maybe 3/8 of an inch off the length of that tang. I'm just going to put some marking blue on there and we'll just see what the fit is like. Okay, we've got a bit of blue on here. Slight impression there a bit, here. I think part of the problem is that there is a dent on the upper side of the morse taper there, and I've been aware of that for some time, but I haven't actually done anything about it yet. So I'm going to get hold of a number 3 morse taper reamer just to clean that up. But for now I think I'm going to stop there because I've got no way really of knowing how I can improve that without cleaning that mark out there. You can see it's left a slight mark there, and I noticed that before when I made the pressure turning tool several years ago. I had the same issue, and yeah. What I'm going to work on now is the other taper into the chuck. Just going to remove the old number 2 morse taper shank. So this is less than ideal, I know, but I'm going to measure off here to set the taper turning attachment as I did for the number 3 Morse taper. So I've got the sleeve which fits in the mandrel down to number 3, and then 3 to 2, and then I put that in there. I've also rotated it to get the minimum run out, but even having done that, I've got 4 thou of total indicated run out. What I'm going to do is I'm going to set the run out so that this is in the vertical position, which is there, and that means that the error across the horizontal is halved. That should cancel it out, and that means I can do the same thing again, track along the front face, set the taper angle on the taper turning attachment, and then hopefully cut that taper. So we're just going to wind in, take up the backlash, zero out, and then traverse. There we are. I think we've set the taper turning attachment up. I needn't have left excess material on like this. I thought I needed more space around the live center to get the tool in with the taper turning attachment. Anyway, I'm reducing the diameter here so it fits through the tailstock chuck. At last we get to cut the J3 taper which mounts in the tailstock chuck. I think it's time to take that out and try it in the jug. Because the beauty of turning between centers is you can remove your work and try it and put it back again. So I know it will pass through. Okay, we've got that much stick out there. I reckon we can take another cut there and just bring that a little bit closer. Yeah, we'll take a little more off that. At the same time I can chamfer this. I've mounted the tailstock chuck together with its new arbor in the smaller lathe, and I'm just going to turn away part of the tang. So here at last is the completed arbor fitted to the chuck. It's a nice fit in the female taper in the chuck, and now we've got an appropriate length of tang. One thing I would have liked to have done is to have case hardened the tang to make it a bit more resilient to dings, but I didn't get around to that. I have some EN8 material which I was originally intending to make this from, but I couldn't find it at the time. But I may as well just use this and see how it stands up to regular use. So you can see we have a much more appropriate amount of overhang, much better than it was before. Let's just give it a quick test. Well, that's this little project completed. I hope there's been something here that's been interesting to you. Definitely there are a few more lessons to learn with the taper turning attachment, but it's a very useful device and it certainly makes machining Morse tapers much easier. I hope you'll join me for the next video to come out in 2 weeks' time. Thank you.